So what we're going to do is we're going to solve a system of quadratic equations. We're going to do it two ways. We're going to do it by graphing, and we'll also do it algebraically. So let's start off simple. I want us to solve the quantity of x minus 5 squared plus y squared equals 36. So we want to solve the system. And the other equation is x minus 5 equals 0. So first we're going to solve this by graphing. And when we're solving a system by graphing, we're taking the two graphs and we're looking to see where they what? Intersect. And their points of intersection, those are the solution points. So let's go ahead and look at our first equation. Not trying to cross it out. Can someone tell me what this is? Are we a line? Are we a parabola? What is this? Matt. This is a circle. Okay. How do I know it's a circle and not an ellipse? Tanya?
Because there's no coefficients.
Good, there's no coefficients here. How do I know that this is a circle and not a hyperbola? Because it's plus, a hyperbola would be minus. Good. All right, and what is the second one? A line. How do you know it's a line? Because it's a degree of 1. So I'm going to, that's not a degree of 2. So I'm going to make this x equals 5. I'm bringing that 5 over. What kind of line is this? A vertical line. Yeah, x equals a number is a vertical line. So now we are ready to sketch. Claudia, can you not see?
I can somewhat see.
Oh, she should know.
Ariana, you could go sit there.
No, like I can see a little bit. Just like as long as
she just wants
to.
Can I move over there and
I just don't.
That's a good.
Put who?
Put Ariana here for fun.
No, Claudia can't sit there. But what I am going to do is, Kritika, I'm going to move you over there. And then, Claudia, I'll put you here.
Oh.
Is that a problem?
I can go over there.
Claudia would be able to see next to tables.
Who's over here?
Nobody.
My vision is not that good.
David's over here.
Oh, David's not here today. Where does David
He
sit?
sits over there. So, no, David can be here. That's fine.
I'll figure David's spot when David comes back. Okay.
No, he doesn't want to sit next to you.
Yes, he does.
So now let's go to the circle and let's graph this. What is the center of the circle? Good, 5, 0. Always the opposite sign. So now, oh, and also what is the radius? 6.
Plus or minus 6.
No, there's no minus in a radius though.
The radius is negative 6.
But you can go down, so can there be a minus?
Well, no, because a radius is a distance, a length.
Oh,
It
yeah.
has to be positive. Okay, so now what I'm going to do is I'm going to plot my center point, which is the point 5, 0.
We need to make our graph.
Yeah, I do. So then what I want to do from there is I'm going to now get other points from the radius. So I'm going to go 6 up. 1, 2, 3, 4, 5, 6. I'm going to go 6 down. 1, 2, 3, 4, 5, 6. I'm going to go 6 to the left. 1, 2, 3, 4, 5, 6. And I will go 6 to the right.
Oh my God.
1, 2, 3, 4, 5, 6. And then we connect our points and create something that looks sort of like a circle. And then the other one, the other thing we have to graph is our line, which is x equals 5. So I'm going to go where x equals 5. 1, 2, 3, 4, 5. And I'm going to draw a vertical line right through that point. So our solution is going to be where our line touches the rim of the circle. Where does our line touch the rim of the circle? In 2 locations. So the solution to this system is going to be the point 5, 6 and the point 5, negative 6. It's where our line touches the circle. So where the line touches the circle.
That was a line equation. I thought that was just like to find the center.
Dylan, you're tripping.
No, like I didn't see the.
It's okay. It's okay. Now you know.
Yeah.
All right, next one.
Wait, so it's not considered touching if it touches the center, right?
No, it has to be the rim. It's not a solution if it goes through the center. The center point is sort of just there to get the rim. All right, next one. So x equals the quantity of y minus 2 squared, and x minus 2y equals negative 4. Again, we want to solve the system. Kenny?
Test, do you differentiate whether we need to solve graphically or algebraically?
I believe some I say you have to, like do it a certain way, and then others I allow you to do it how you want. Okay, so number 2, the first one, x equals the quantity of y minus 2 squared. What is this? Aditya? This is a horizontal parabola. You got it. How do we know it's a horizontal parabola and not a vertical parabola?
X equals y squared instead of y equals x squared.
Good. A vertical parabola is y equals x squared. Horizontal parabola is x equals y squared. What is the vertex here?
0, -2.
Perfect.
No, 0, 2.
0, positive 2. You got it. All right. And let's get the x-intercept also for this parabola. So the x-intercept is x equals the quantity of 0 minus 2 squared. So it will be the point 0, comma 4. All right, so I think we have enough to sketch this now.
It's 4, 0.
Oh, sorry.
4, 0.
4, 0, you're correct.
Absolutely not. I did 4 0.
I wrote it the right way. Hey.
I put 4, that would be 0.
Okay, so let's do this. So our vertex is 0, 2. And then we have an x-intercept of 4, 0, 1, 2, 3, 4. And do we agree the axis of symmetry would just be right through the vertex? Yes?
Yeah.
All right, so here's our vertex, here's our axis of symmetry. We have 1.2 units below it, the axis of symmetry, so shouldn't it be sort of mirror images on either side of that axis of symmetry? So if I'm 2 below, wouldn't I also be 2 above? So we're right over here. So I just drew that axis of symmetry to just help me find the other point to plot. All right, so now we have another graph. Our other graph is x minus 2y equals negative 4. What is this? A line. How do you know? Degree is 1. So what I'm going to do is I'm going to put this in slope-intercept form. When I say slope-intercept form, I want it to look like y equals mx plus b. So I'm going to, I'll leave the x there. I'll add the 4 over, and then I'll add the 2y over. And then I'll divide by 2 under everything. So we're going to get y is equal to a half x plus 2. Yes. You're good?
Yeah.
Okay. So now my slope is positive 1 over 2. My y-intercept is 2. So now I'm going to go ahead and I'm going to graph this line. We start at the y-intercept. Do we already have a solution? Yeah, so we know one solution is the point 0, 2.
That's the only
Nope, we got to keep going. We got to graph our line to see if it's going to touch again.
It's that other point.
So then we're going up 1 to the right 2. Oh, I went to the right 1, not to the right 2. Up 1 to the right 2, and then up 1 to the right 2, up 1 to the right 2. Then down 1, left 2. Am I good enough to stop here? Yeah. Solid line. So we do end up having another solution. What's our other solution? 4, 4. Yep. All right, now we're going to talk about solving linear quadratics algebraically. Are we ready? All right, so I'm going to do a problem, and as I do the problem, I'm going to write out the steps for you. So if we want to solve this problem algebraically, if I have x squared plus y squared equals 13, and negative 2x plus y equals negative 1. So in my opinion, when you have a quadratic linear system, so one's a degree of 1, one's a degree of 2, the best route to solve algebraically is probably through substitution, in my opinion. So what we're going to do is we're going to go ahead and we're going to take the linear equation, and I'm going to solve for one of its variables. So step 1, take linear equation, solve for one of its variables.
Could you do elimination?
So elimination would be really difficult because you're in different modes. So one is degrees of 2, the other's degree of 1. So because they're dealing with different degrees, substitution is by far the easier method. So now what we're going to do is we're going to take our linear, so our step 1, and I have negative 2x plus y equals negative 1. Which variable is the better one to solve for here? Aditya? Y. Why is y the better variable to solve for?
Because it's already isolated, doesn't have coefficient.
Good, there's no coefficient, which means the other side won't be a fraction, which is really helpful. So I'm going to add that 2x over. So we're going to have y is equal to 2x minus 1. Now that I've solved for one of the variables, I'm going to go back to the quadratic equation. And anytime I see y, I'm going to now substitute in the 2x minus 1. So step number 2. Substitute result from step 1 into the quadratic equation. Instead of 1, 2, let's call this AB. All right, so now I'm taking my quadratic, x squared plus y squared equals 13. I'll wait for you all to catch up. We caught up? Okay, so now we said y equals 2x minus 1. So I'm going to my quadratic. Wherever I see y, I'm now going to substitute in the 2x minus 1. So we now have x squared plus the quantity of 2x minus 1 squared equals 13. right, now we have to FOIL this out. So we are x squared plus 2x minus 1 times another 2x minus 1 equals 13. This is not 4x squared plus 1. It is not 4x squared plus 1 when you multiply that out. If you can multiply it in your head because you know it's a perfect square trinomial, you can. If you don't, double distribute, FOIL, whatever it is that you do, just do not write that it's 4x squared plus 1. So this is 4x squared minus 2x minus another 2x plus 1 equals 13. So I double distributed the 2x and I double distributed the negative 1. So now we are at x squared plus 4x squared minus 4x plus 1 equals 13. I can combine my like terms here. We have 5x squared minus 4x minus 1 equals 13. What am I, oh, plus 1, sorry. What am I going to have to do? So we can do what? So you can do what? Factor. So we can factor. Completing the square would work, but it's unnecessary work. All right, so I'm going to subtract the 13. So we are 5x squared minus 4x minus 12 equals 0. And then you factor this. Did anybody factor it?
Yeah.
What'd you get?
What'd we get?
I did quadratic by accident, so I have the
By
answer.
accident?
Okay, did anybody factor?
Factored.
Okay, what'd you get?
5x equals 6 times x minus 2.
You got it.
Good job.
So then when we factor, we get 5x plus 6 times the quantity of x minus 2, and then you have to solve. So you set each factor equal to 0, and we get x equals negative 6/5 and x equals 2.
That's all.
Okay, we're not done. What do these represent?
X, when they intersect.
This is the x-coordinate where they intersect, but we need a point, right? We have a graph. We want to see where these two cross. You need an x-coordinate and you need a y-coordinate. So our next step,
You have to plug in both of them.
yeah, well, why just one? How many solutions are there?
2.
So you have to plug in both of them. So now what we want to do is substitute x values to find other variable. So now we had x equals 2 and x equals negative 6/5. So I'm going to go back. Do you think it matters which equation I go back into? Absolutely not. I'm going to go back to the linear equation. So y equals 2x minus 1. And I'm going to substitute first in my 2, y equals 2 times 2 minus 1. So y will equal 3. So what's my first solution?
3.
No.
2, 3.
2, 3, yeah. You have to write it as a point. 2, 3. Right, now we're going to do the same thing, but for x equals negative 6/5. So y equals 2 times negative 6/5 minus 1. So y equals negative 12/5 minus 1. We're going to have to create a common denominator. So negative 12/5 minus 5/5. So y will equal negative 17/5. So the solution here is negative 6/5 comma negative 17/5. Let you finish copying. I'm sorry?
I said surprisingly Dylan was done copying
Yeah.
before everyone else.
It's the new seat.
Yeah, it is. That's what it is.
Could you, like, plug the x back into the original equation?
Absolutely. You could have plugged it into any of the equations.
But then for the x squared plus y squared equals 13, don't you get plus or minus? So, like, how do you pick?
So when you...
That's true.
So when you're saying when you do x squared plus y squared equals 13, if we plugged in the 2,
Yeah.
2 squared plus y squared equals 13, I see what you're saying. So then, that's a great question. So I guess we'd have to use the linear one.
Wait, but then it's a.
Oh, wait, no, no.
If it's a line, it can't really. Can it be in 2 points at the same time?
No, it can't. So we would have to have used the linear equation here to plug back in. Because we got, when we plugged back into x squared plus y squared equals 13, if you plug the 2 in, we have 4 plus y squared equals 13, so y squared equals 9, but then you get y equals plus or minus 3. You would have to then test it, because you got the plus or minus 3. You would then have to test it in the linear one anyway. Well, it's not really an extraneous solution. You'd have to test it into the linear one to see, well, it can't be, because it's not like a vertical or horizontal line, so it can't be at those 2 locations when x is 2, so you'd have to see which one it worked out to be. So regardless, you would have ended up having to use the linear one once you plugged into the quadratic one.
So you should always use the linear one?
If the linear is an option, yes. Okay, so how many solutions can a linear quadratic system have?
We'll see. Want to take a guess?
2.
We'll say 3.
2.
All right, so we can have, we can definitely have 2, right? We could have 2 points of intersection. Could I ever have 3 points of intersection? Would this ever be possible to have 3?
No.
Never. So we have definitely at most 2 points. That's an option, right? Well, let's see. Let's think of a scenario. Do you think there can be one?
Well, if you hit the vertex, if you hit the vertex.
Exactly. If you hit the vertex, what about a vertical line?
It's undefined.
What?
It's undefined. It's supposed to be undefined.
So you can have a vertical line, yeah, like that.
For a vertical line?
Yeah.
X equals?
X equals whatever the x-intercept is. Okay, so we can definitely have 1 point, right? So we can have 2 solutions. We know we could have 2 solutions. We can have 1 solution. Can you have 0 solutions, do you think?
Yeah.
Yeah, absolutely. Right? Wouldn't that be like a 0 solution? Or this is a no solution. So how many solutions can a linear quadratic system have? At most 2. At most 2. All right, so now we're going to talk about quadratic system. Or you know what, let's call this conic systems. Okay, we can have mechanics I'm going to be talking about is, let me tell you, we're going to have circles, ellipses, hyperbolas, and I guess we can still, I guess lines still fall under quadratic systems, right? We can have, oh, parabolas too. Thank you. Thank you. All right, we can have 0, 1, 2, 3, or 4 solutions.
Isn't the amount in like the highest exponent actually not how to make sense?
No.
I didn't see anything.
So we can have 0 solutions, which is a no solution, 1, 2, 3, or 4 solutions. Let me show you examples. Okay, so let's say I have this, and I have that. Obviously, what would this be? A no solution. No points of intersection at all. What about this? 1 solution. How many solutions here? Oh, it's really bad drawing. Oh no, what happened here?
Oh wait, where'd it go?
It went to geometry. It's quitting.
Uh-oh, the recording.
What happened to the recording now, do you think? It's still recording? Okay, good. Okay, let's try this one.
Yeah. Yeah. Did you get the PSAT then?
Yeah.
You get 12.
Wow.
I'm screwed.
No.
All right, so this is an example of like a 3 solution system. Guys, Dylan, I'm gonna have to move you.
What? No, okay, sorry.
He's asking an academic question.
Yeah,
No.
the PSAT for geometry.
And the very last one would be 4 solutions. Could look something like this. 1, 2, 3, 4. Mm-hmm.
It could just be a hyperbola, maybe a circle.
It could be.
Does that have to be that bad?
Depends on what I give you.
All the problems with the test are going to be that bad, though. You have to do it.
I don't think this test is bad.
That's 3 and 4. Can we
That's when you
discount
know
one
it's
of our
bad.
choosing? Like, not count one of them?
What?
No.
When has the teacher ever let that happen?
Yeah.
Okay,
That's something that you
so I want us to solve the system by graphing. The truth is, if I ask you to graph, it's not going to be sloppy numbers. If I'm asking you to solve by graphing, obviously it's not going to be like a radical solution because that would be pretty difficult. But those radical solutions will come when I ask you to solve algebraically. So let's say we have x squared plus y squared equals 13. And now I have x squared minus y equals 7. Okay, let's talk about what we have here. Left side is what? Circle. Right side is? A vertical parabola. DTO, is that you?
Yeah, that was it.
Very good. All right, so I'm going to manipulate the second one so it looks like a vertical parabola. I'm going to add the y and then subtract the 7. So we are at y equals x squared minus 7. So this is the same as y equals x minus 0 squared minus 7. Mm-hmm. All right, let's sketch this.
No wonder the left be like 36 instead. Because it's easier to graph.
13's a pain.
Maybe 16, round up.
Oh, well, 13 is a pain. Let's make this nicer.
16's close enough.
Okay.
I appreciate it without it.
Well, we're going to see. This was not really a great one for me to do.
We're gonna see the homework.
Okay, okay. It's much easier to do the lines graphically.
Oh, we just skipped the problem.
Just stop right here.
No, I got a good one. I got a good one. We ready? Sorry. I got a good one now. That's going to work.
Can we just go back to skipping this year?
It's going to be hard to find those solutions. Okay. I'm just going to... All right, how about I change the question? Leave that. And we'll ask how many solutions. How about that? How many solutions? That's more along the lines of what I'd ask. So we'll leave this 13. How many solutions will this system have? That's a better question. More realistic. Yeah.
That's
That's just the kind of sort of graphic it.
Yeah, like this is like, you need to know what you're doing to sketch it, and then you'll know, but then you're not like finding crazy decimal things. Okay, so here we're going to go ahead, we're going to graph our circle first, which is at 0, 0. And then our radius is not 13. Our radius is the root of 13. So what do? We have to estimate. So we're root 9 and root 16. So we're between, not 4, we're between 3 and 4, but closer to the?
6.
Sure. Okay. So now we are going to sketch our radius. Let's see, 1, 2, 3. I'm doing like 3.5. 1, 2, 3. 1, 2, 3. All right, so here's my circle. And now we need to draw our parabola or sketch our parabola. And we know our parabola's vertex is what? 0, -7. You got it. And are we smiling? Are we frowning? Are we going to the right, opening to the right, opening to the left? We're opening up. Exactly. So this is just a nice little guess here. Actually, let's find the x-intercept to help us out to know how wide this is going. So we're going to find x-intercept. So we're going to have 0 equals x squared minus 7. So 7 equals x squared. So what does x equal? The root of?
7.
Plus minus root of 7, right? So then we are between
4 and 9.
4, 9, and
2.6.
root 4 and root 9, which is between 2 and 3. 2.7, yeah, 2.8, good. So now we are 0, 1, 2. I'm just doing 2.5. 0, 1, 2. So how many times are we intersecting the circle? 6. 4 times. 1, 2, 3, 4. There you go.
If they had two circles like on top of each other,
Yes. There used to be one circle. It's
But then it'd be the same equation.
It would be the same equation.
You're welcome.
Okay, so we did that. Now no, we're not done. All right, now, oh, here's a nice one for you to solve graphically. I want you guys, actually, let me solve one algebraically.
and then we'll do one graphically independently.
Yeah, and then we'll be done. So we're going to solve this algebraically. X squared plus y squared equals 49. And then we have negative 2y squared equals 30 minus 2x squared. So when the two equations are in different degrees, like one had like a degree of 2, one had a degree of 1, I said elimination is probably best, right? When they have the same, I'm sorry, I said substitution before was probably best. When they have different degrees, like a degree of 1 and a degree of 2, substitution is your best option. But when they have the same degree, I always prefer elimination if that's an option. And because they have the same degree, elimination is an option. So what I'm going to do is I want all the x's and y's on one side together, everything that doesn't have a variable on the other side. So our first equation is good. We have x squared plus y squared equals 49. The second equation needs some manipulation. I'm going to add the 2x squared over minus 2y squared equals 30. Before I line up the two equations for elimination, does anybody see what I could do with the 2x squared minus 2y squared equals 30? I could divide the whole thing by 2, which will make my numbers a lot easier to work with. So we're x squared minus y squared equals 15. So here we have x squared minus y squared equals 15. Well, this actually turned out really nice, didn't it?
Wow.
Because if I add these two equations together, what happens with the y squareds? They cancel out. So x squared plus x squared is 2x squared equals 64. Divide by 2.
Plus or minus 6.
No. X squared equals 32. We need to root both sides. Guys, you have to simplify your radicals. So x equals plus or minus 4 root 2. What do we have to do now? Plug back in to find y.
I would do the 49 one.
You want to do 49? Yeah. All right, let's do 49 one. So we have x squared plus y squared equals 49.
Which one are you plugging in? Plus or the minus?
It doesn't matter because you're squaring it. So we're going to have 4 root 2 squared plus y squared equals 49. So this is going to be 16 times 2 plus y squared equals 49. 32 plus y squared equals 49. So y squared equals 17. So y will equal plus minus root 17. Okay, so how many solutions do we have here? 4. We have 4 solutions. We are plus minus 4 root 2 comma plus minus root 17. So you have those different combinations of the plus minus.
We could write our answer like that on the test. We don't have to like write out.
Absolutely, you could write it out just like this.
I'm not even know if I can get to this part, but we'll see.
Oh, so one more.
Yeah, I'm looking to see. Yes?
If we're solving algebraically, if you want us to estimate the solutions,
If you're, say it one more time.
For solving algebraically, should we estimate this?
Never. So when you're solving algebraically, I want the most accurate solution, which is the radical. All right, I'm going to have you try one by yourself.
Can you give us a graph of the line?
No.
No. I'll give you...
Yeah.
That's true.
So we can do it too.
That's like a nice little question for us to
Refresh our
test two
memory.
lines.
Yeah, this
You
is
can do like
fun
an
enough.
extra credit one on the test.
You never got that one.
2 lines will always only be 1.
Yeah.
Or 0. Yeah, 1 is 0.
Robin, why are you like testing?
Just to see.
No, John, what if it's like this?
What?
It's like this.
Okay, this one works out nicely. This one works out nicely. No crazy radicals.
Wait, algebraically or graph?
No.
Set up. That's a what?
Oh, like
That's an ellipsis, right?
It is.
Ellipses, Dylan.
ellipses is plural.
Ellipses.
Only one ellipse.
Thank you, Kim. No problem.
Wait.
So we have an ellipse and then we have a circle. Ravi, did you just say line?
It's looked out, but I was thinking, so.
What did he say?
He said
Nothing.
Circle and
Plus,
perfect.
I'm almost done with my book.
I'm on my third book.
This is my
I'm
second book.
still not finished.
That's because
I've only had 5
But
chapters
you'd
in
be
this
like
book.
book 1.5, which is why what I want, because you waste half your pages.
For
You
me?
don't need the in between pages.
Yeah.
They're corrupted.
What in between?
It's just the back.
So you'd be book 1.5, just about where I am.
But the back is for Dylan to make modern art.
Bro, how you doing?
Oh wait, you just intersect
I
twice.
forgot to do ellipses.
What do you do? What do you do?
Right?
What?
They intersect twice.
Hey, you nothing.
Oh wait, this looks like an eye.
Wait. How do A is 4
Wait,
and
it's not
B is,
hard.
B is 1?
A squared is 4, so A is 2. Guys, A squared is 4, so A is just 2. And B squared is 1, which means B is still 1.
I still don't. That works.
So do we want to see me sketch this?
No, I need to do it. I need to do it yet. Don't miss out on it, please.
Okay, I'm not doing it. You got this, Dylan.
Dylan does not got this.
Dylan's got this.
Come on, Reese, have
I
some.
don't believe in
No, you should let Dylan graph it for the entire
Oh,
class.
no. I don't know if I could do that.
I thought you guys weren't friends anymore.
We just talk a little.
You're not friends, but you still talk. That's great.
Yeah, something like that.
I thought you said you hated him.
Yeah, that's what he said.
Bro, what about those conversations in the chat?
Oh my god. I think I graphed it. I got it.
All right, let's go over this now. So the center of our ellipse is 0, 0. And then our A is not 4, our A is 2. And because the A squared is under the X, that means we're going along. Yeah, so that means our x-axis is our major axis. So I'm going 1, 2 here, 1, 2 here. And then our y-axis is our minor axis, so we're going up 1 and down 1. So our ellipse looks something like this. Now our circle is centered at 0, 0. But the radius is 1, so we're up 1, down 1, left 1, right 1. So what are our solution points?
0, 1.
Plus, minus.
0, 1, and 0, negative 1. You could do 0, comma, plus, minus 1.
That's a drawing.
All right, we're done for